questions in it. What's up, AP Stats? Hope you're having a great day. We got some people in here.
Yeah.
We got Torrance. Where y'all at? Where y'all at? We got Jared and Jackson in here, and we got Josh over here in the corner. He's hiding on this side. Hey, just because we do it every time, we're gonna shoot right here. The initial inaugural shot, as we always do. Here we go. I'm gonna drill this one. This one goes out to who should I dedicate this to?
To your almost child.
Almost child, Bennett. Here we go.
No, if he
No,
misses, like,
I'm gonna hit it. I'm very confident. All right, never mind.
okay.
That wasn't even. Never mind. Forget that.
That's what I said.
Forget that one. That was. Yeah, I never said that. All right, but we are live, so I can't go back on this. Hey, let's go ahead and get started. This mess. Actually, the three people that are in this room, I don't know if y'all have seen it. I just saw that shot. Great shot. Jared just drilled the shot. That was actually really, really nice. Okay, really nice. Okay, so here's the thing. I'm going to, I think I said this in the group name. It looked like a heap of mess.
I saw that big photo.
What I did was I decided to put everything down, like formula-wise and big picture-wise. These are the things that you, like, no questions, have to know, okay? I did this in the other class, and I think I'll podcast and put this down as well. I'm going to do a brief version of that. If you, for some reason, are at home and you're like, Coach, I want more details on that, I did it with the last class, and I podcasted it. And so go ahead and check that out. All right, go ahead and check that out in a little more detail. Just real quick, a couple of things, and stop me, guys, if you have anything that's like you gotta have. Other than that, we'll go through this. We'll go through some example problems, and remind me to look over the concept list too. Okay. All right, here we go. Geometric and binomial. The B, the I, the S are all the same, right?
Yeah.
Just real quick, what's B?
Binomial.
No.
Binary.
Binary.
That's what I meant.
Related with binomial and geometric. Good. What's I? Independence.
Independent.
S is
Success.
percentage is the same. Good. And remember when we state that to be able to provide evidence on each of those, okay? What is the difference between binomial and geometric?
Spelling.
The spelling, yes.
One has a set number of trials, and the other one is just until you get it or don't get it. Or no, yeah, that's right.
Great job. Yeah, so T would be for bits, geometric trials until success. Binomial is the total number of trials. The last FRQ, I'll be honest, has 3 different scenarios. I'm telling you right now what it is, okay? The last FRQ has 3 questions. One of them is a binomial, one of them is geometric, and one of them is neither. You'll recognize that, and you'll have to identify, oh yeah, that's neither binomial or geometric, and you'll just have to use your knowledge from your probability unit to just attack and solve, okay? It'll be obvious there's 3 different types, okay? All right, Torrance? It might not be normal. It might just
I know what it
be.
means. It would be like using, I don't want to say it.
Go ahead.
Like using like the 10% rule to use your binomial or something like that. Or like it would be neither, but once you realize it's 10% rule, you could use the binomial. Is that what you mean?
No, it's actually different. It would be like, it would be a situation where, and here's the deal. I don't tell you this is binomial, this is geometric.
Yeah.
You're going to know which one's binomial and geometric based on what we just talked about.
Mm-hmm.
The third one, I wouldn't really as much stress over that, but just kind of understand that, okay, trust me, like this is going to be pulled from like how I would attack a probability. Basically, it's kind of common sense.
Okay.
Correct? I don't want to say, yeah, I wouldn't worry about it too much.
Okay.
Just know that there's one of each types. Correct? All right, good stuff. Remember the formulas down here? You'll have these formulas like here and here. The big thing that you need to know is that you'll have them. You'll need to know which it's used for. I think it's easier to be able to memorize them. I could draw my formula sheet, but that might be just something just to keep in the back of your mind for that one. That's there. Okay. So we got geometric. Notice there is no standard deviation for geometric because it changes because there's not a set number of trials. And then you've got mean and standard. Anything over this box? Y'all feel pretty good? Cool. Let's go over to the example side because it relates to it, and then I'll go to the top left. Remember with geometric, an example would be like I roll a dice until I get a 6, right? So that would be geometric. The probability of the second roll being a 6 would be an example of x equaling 2. Probability of the second roll equaling 2 for a success, right? Within that, why do I say geom PDF and not CDF?
So you're trying to
It's
like that.
just the second roll.
Yeah, just the second roll. It's not cumulative, right? So remember, PDF would be there. Where's the n on this? Why do I not have an n?
Because it's geometric, so you don't get a set number of trials.
Yeah, y'all are all right on this. No set number of trials, right? But make sure if it's on, like the example on the FRQ, don't just put geom PDF and then plug them in. Make sure you put P and K.
Is
Josh,
the camera on the whole time?
it is.
Josh did something stupid and the camera was on it.
No, it's no, I'm messing with you. It's not there. Right now, it's sharing my screen. It's sharing my screen. Okay. At least I hope so. Otherwise, oh no, we're good. See, that's what people are seeing right now. All right, very good. Just don't cuss or do anything like that. Because he's completely live.
He went.
No worries. Maybe at the end, we'll have you do that at the end.
No.
All right, so this one is the probability of x being less than or equal to 2. Make sure, again, geom CDF, establish P and K, and then afterwards plug in the values once I've established what the formula is, okay? All right, questions on this? Okay, so this is a little weird. What if I said, what is the probability of x being greater than or equal to 3? What is the probability? I'm putting this off to the side. Now remember, and let's say it was geom still, same thing.
Would you do CDF and then subtract it from 1 so you can get the other part, so you can get the bigger part?
Good, so what the P would be 1/6, right, for this? And what would be the K?
Wait, the number of successes, like until you get a number above 3.
So 3 or greater, right? 3 or greater. So we would have to use CDF to do anything that was, because remember CDF is only
It's
that
less.
value or anything less than that value, right?
Yeah.
So what would be the K for the geom CDF before I subtracted it from 1?
On a dice, would it be?
Would it be 2? You think about that? So
Oh yeah, you're trying to get 3 or greater.
yeah, so like right
Oh,
here,
yeah.
I'm gonna come back to this. But if this is 1, 2, 3, 4, 5, right? 4, 3, 2, 1, and even, yeah, that would be it. And let's say I want anything that is 3 or greater than. Geom CDF can only find anything that's that value or less than. So I'd have to find geom CDF for this area right here, and then subtract by 1 to be able to get this area.
So find the GeoCDF of less than or equal to 3 and then subtract that answer by 1.
Less than or equal to 2.
Oh, less than or equal to 2.
Because what did it say? It said
Oh,
greater than or equal to 3.
okay.
Am I making sense on that?
Yeah.
It's a little tricky. Okay. Now binom, we have a set amount. X is equal to 2. 2 free throws out of 10. Less than or equal to. Remember, we have an n because we have an n number of trials, number of free throws. We're good there. Okay. Questions on this? I think y'all feel pretty good on that. Okay, good. This formula down here, just be familiar with. This one relates with the binom PDF. It's really not something I ever use in terms of a FRQ. I always go to binom PDF and then NPK and then plug it in. But on a multiple choice, this could be a possibility. Okay.
Can we go over that? Because I had a question, I think, on the multiple choice for the review. I was going over last night. I think I'd used that for one of them, and I forgot how to use it.
Yeah, good question. What's n out of 10 free throws?
And out of 10,
So
10, right?
10 sample. Yeah, K is X equals 2, right? So K would be
2,
2. P would be, if I'm an 80% free throw shooter, let's say,
so 0.8.
0.8 to the second
Second.
power. And what would this be?
1 minus
0.8.
Which would be
0.2.
0.2 to the n minus K, which would be
10 minus 2.
which would be the
8.
8th power. Good. And I would plug that in my calculator or just be able to see it. Remember, 10C2 can also be n over K in parentheses. This right over here and this is just another way to say it, okay? Are we good?
Yeah.
Cool. A random variable. Let's talk about that real quick. A random variable is something that could be two things: discrete or continuous. Continuous is
There's like no
Like
numbers.
any-
There are numbers in between. It just keeps going.
good. And what's discrete?
It's like a big set of numbers, like with no gaps.
No gaps, right? Yeah. Or I'm sorry, discrete would
No,
be
discrete.
Discrete has, it's like an
gaps.
amount
with
of
gaps,
something.
right?
Yeah.
Shoe size, amount of tackles I have in a game, amount of free throws I make. That's a good example. I knew what you meant by that. Also, random variable has to have two things. Number one, has to be numerical. So if I say whether you answer yes or no on whether you think AP Stats is Gucci or not, that would be something that would not be a random variable, right? Because that's not numerical, all right? Also, it's got to be random. So there's got to be some sort of randomness to it. The amount of money that I'm going to win when playing blackjack in Vegas when I go in January, okay? Which I'm not. I know this is
No,
not a
we're not together.
podcast. Yeah, that's right. When we go and play blackjack as a class, okay?
Good trip.
Does that make sense? Yeah, field
Yeah.
trip. They think we're going to Turner. But
Yeah.
we're not. We're done. Casino. I think
We
there's
said
a-
Turner. We didn't say where it was. There's probably one in Las Vegas.
What we should do though, we should just like bring it to the like casino stuff in here as like.
Yes,
class
he has
activity.
he has his chips up there.
Oh yeah, and we just like play poker. You get, like just find what are the odds of everything.
we should.
We should.
That's a good idea. You got me thinking now. It's good stuff.
Let's do it.
All right.
In there.
The next thing. This is something that that's all that. Something that people struggle with. These two things. Okay. The 10% rule versus when we use normal approximation. Do y'all struggle when we use that?
10%
The
rule
difference
compared to,
between these
the
two?
large number rule, or
The rule of large
Mhm.
numbers. Okay.
Yeah, these are the two differences. When something fails independence, we don't replace it, right? We choose one Skittle out of 10,000. That's not independent, right? However, if the 10% rule is true that the sample size is less than or equal to 1/10 of big N, by the way, these are not on your formula sheet, by the way. So if you're at home and you're checking that, those are not on your formula sheet. If this is true, then we would say that even though it's not independent, we're still okay to go with the geometric or binomial,
Mhm.
okay? But you've got to show this. Or you've got to say the sample size is less than or equal to 1/10 of my big N.
Wait, so what's like the exact like situation when you use either one of those?
So 10% rule.
Yeah.
I have a bunch of Skittles, right? I go to the factory. I randomly select 10 to fill a fun size package, okay?
Yeah.
When I do that, I am not taking a Skittle and replacing it and then selecting the next one. So because I'm not doing that, that's technically a dependent event, but the change is so small that the probability doesn't change from one to the next by very much.
So would 10 be like what you're comparing to 1,000?
Yes.
Exactly.
Okay.
So 10 is less than or equal to 1/10 of 10,000.
When would you use the law of large numbers?
The law of large numbers is the blue box over here. That is used for a binomial. And a binomial, remember I said that sometimes if it's so large, remember the thing where I like increased the sample size and it like became more and more normal looking?
Yeah.
Remember I kind of showed that? That's this. That if a binomial is so big that n, the sample size times my probability is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10, we can approximate a normal distribution, approximate a binomial with a normal distribution.
Okay.
And you would get approximately the same answer.
So like if you like flipped a coin like 10,000 times, it's gonna be approximately.
The probability of getting heads, we'll say, 10,000 times. That's a great example. That would be a binomial. It's a binomial. But also you could estimate it with a normal approximation. I know it's got like messed up today. But that's my shirt, so we're good. Felt weird all day on that. So thank you. Thanks for pointing that out.
You're welcome.
It's
And then this is for really, I was not a
He was
camera
really
this
self.
time.
He was really self-conscious.
No,
Come
let's
on.
actually put it. Never mind. Yeah, we're good. Let's say we have two random variables, x and y. Okay, and we add the two together. What happens to my means when I combine them together?
And you add the mean.
You just add the means, and that's where we get this here. Same thing. If we subtract the two values, we just subtract the mean to get the new one,
Mhm.
right? That's pretty easy. But we remember with standard deviation,
one does not simply add standard deviation.
Yes, and if you're at home and did not do the symbol, shame on you, okay? I will haunt you. Remember that when we subtract or add, the standard deviation formula stays the same, right? The square root of the standard deviation squared of x plus the standard deviation squared of y. By the way, what is the standard deviation squared of x really?
Square root of x, it's variance, right?
Yeah, it's really like technically you're finding the variance of each.
Mhm.
It's good, yeah. So that's technically, I didn't say that, but it's also something to remember with variance.
Oh, I didn't see
Okay?
You didn't even see that.
That's right here.
Yeah, of course you didn't see that, Jared.
Yeah.
You're so
Jared
smart.
knew the
Wow.
answer. Yeah. All right. So questions on this? I hope that helped. We literally did. That was quick. That was really quick. But that's a lot of the formulas and stuff that I would make sure I looked at. So, okay. All right. So y'all are here. Do y'all have any questions for me in terms of stuff that you maybe were struggling with?
Oh,
Go ahead.
wait. Nope, I got it. Never mind. I just figured it out.
I only had a question on the NCR, but we answered that.
Cool. Yeah.
So I think
It's a pretty good one. There's a couple that people were struggling with on the review we did, both in class and the one that's online, that you'll do for tonight, right?
yeah,
Right on.
of course.
Did you see that?
Yeah.
Low key. All right. Let's go. Let's do this. If we did number 3, it's a tough one. It says a deck of cards contains 52, of which 4 are aces. You're offered the following wage. Draw 1 card. If you win $10 if the card is an ace. Otherwise, you lose $1. I think this was off the homework, actually.
Yeah.
This is on the homework and it's on the review.
I think we did it all in class one time or something. This
Yeah.
sounds very okay. Whatever. Just continue.
We'll continue. So what will be the main amount you win? This could also be interpreted, what is the expected value that you would expect to win?
Yeah.
The struggle that I find is how do I change this into a probability distribution, right?
We'll either get -1 or you get.
We notice that you win or lose depending upon what happens, right? And so if I ever see something that's like this, I would set this up with x being the value that I get out and p of x being the probability of this occurring, okay? So hold on just a second. Sorry, I'll use my wife just in case. Hey, babe, I'm on a podcast. Is everything cool? Okay. All right. Sorry, y'all. Everything's good. That would have been awesome if it was on a podcast.
That would be crazy.
It's gonna be crazy.
Because you podcast too much.
I know this is true.
I
podcast half my life.
Too much.
There's no such thing as podcasting too much.
This is true. So what could be the output for me? I could either have 2 things happen, right?
$10.
I could have $10 that I gain,
Less or not $1.
or I could subtract or get $1 that would decrease. So what would be the probability of getting $10?
4 out of 52.
Good. 4 out of 52, and -1 would be
48 out of 52.
48 out of 52. So if I said, hey, how do you find the expected value? Knowing how to show this on an FRQ and then also just be able to plug it in my calculator or just find it is important. So we multiply here, we multiply here, we add those together to get what my expected value would be, okay? And then you'd be good to go. So then if it was negative, you would lose that amount. I think it ends up being C.
It's C, yeah.
From what I remember. So it'd be negative 0.15. So on many trials, you would be expected to lose about 15 cents there.
I did it a little different way. So once I didn't do a table, but I basically got 4 out of 52. So I timed that by 10. So I did the multiplication, got 40 and then 48. But then I subtract, or then I subtract them to get you're expected to lose $8, but then divide that by 52 per hand, and that equals that. Is that the same thing, really?
Pretty much the same thing,
Okay.
yeah. I would say just be sure that you know how to create a probability distribution, because this one's maybe not as difficult, whereas maybe other ones on the test might be.
Yeah.
Cool. Torrance?
Wait, remember that one FRQ question we did in class? It was like that standard deviation problem. Well, it was like find the mean standard deviation, and then like it had that whole entire formula, like that long square root.
Oh, yeah. You
Yeah,
told us the board.
You're not going to have to do that on the test.
You said the
Cool.
board had to make it.
Here's the thing. There's some things on the AP exam that I'm willing to say, you know what? More power to you. I'm not worried about it. That's one of those things.
So would we just use the first bar stats to find it?
That's what I would do. So if I said find the standard deviation of this, L1 would be the x, L2 would be p of x, and L2 would be our frequency. Good question.
Okay.
Cool. Yeah, I'll do this. Do you see any on numbers 1 and 2? Do you see ones that you struggle with?
Nope.
Expected number of cars. That's the mean we just found, right?
Yeah.
So that's just interpretation there. Do you know how to interpret a standard deviation here?
What do
So
you
if
mean
you-
interpret it like?
Like if I said interpret the standard deviation of this probability distribution,
So
could you do
finding it basically, or
finding it, but then
and
in
then
context,
describing it. Okay.
what is standard deviation?
Average distance from the mean.
Average distance from the mean. We also could say that it typically varies by whatever your standard deviation is from the mean. Okay? Does that make sense? So if we did many trials, or on average, we would expect it to be this far away, typically from the mean. Kind of say it a couple ways. Number 1, Helsing builds houses with 2 cars. What % of households have more cars than the garage can hold?
Is that the standard deviation? Wait, no.
No, that's B.
If they build with 2-car garages, this is the
Yeah.
number of cars, right?
Yeah, oh.
What would we be looking
yeah.
for?
Oh, a probability
So
of it being greater than 2.
3 or above, right?
Yeah,
And if
2
I were to
or
write that
above.
on an FRQ, that'd be P of X is greater than or equal to 3. This is not necessarily a binomial, so be careful on that, right?
If it's
This would just be adding the probabilities together.
if it's like discrete, like number of cars, would greater than or equal to 3 or greater than 2 be the same thing?
Yes, it would be.
Okay.
That's actually a good point.
What is that?
If it's discrete, so it's like you can like have half a car, would
Yeah.
greater than 2 be the same thing as greater than or
Oh, okay.
Actually, a really good point. Yeah. I usually view greater than or equal to, but yeah, that works. All right, here's another one. This is kind of a new one. Draw 1 card at random from the deck. If the card drawn is a heart, you win $2. Otherwise, you lose $1.
13.
I remember doing this. It gives you 13 cards.
Have we done? Or you just?
No, I just did the review last night. I did most of it.
Oh man,
I got ahead of the game, so for the first, I promised you I did.
y'all, we are experiencing miracles right now. This is like, I'm joking.
Yeah.
No, you're not. No, you're actually really on
It's
this.
something ahead of the
This is
next
good. This is good. All right, so number 4, a heart is $2, right? Or you lose $1. So what's the probability of getting a heart?
13 out of 52.
Good. And then what's the probability of getting non-heart?
39.
39 out of 52, or whatever the difference was. Same thing. I would get the expected value, and whatever the expected value was, we want the one that gives me more in the long run, right? So this would actually be 26 over 52, and this would be minus 39 out of 52.
Yeah.
The game that I would prefer playing, this would be negative 13 over 52,
Which is 0.25.
negative 0.25. Good stuff. So which has the higher probability?
A.
A would, because it has negative 0.15. Therefore, I would prefer playing game A over game B if my goal was to have more money or gain more money. Right? Cool. That's a good one. Oh yeah, this is kind of from what we were talking about earlier. Basically, the idea is the number of calories in a 1-ounce serving breakfast has a mean of 110, standard deviation of 10. The number of calories in a whole milk is a mean of 140, standard deviation of 12. If we combine this for breakfast, you eat 1 ounce of the cereal with half a cup of whole milk. Let T be the random variable that represents the total number of calories. This is a good one in the breakfast. Okay? All right. So what do we got going on? What makes up a entire bowl? What makes up the total?
The total
Like
would
the
be.
mean of the breakfast.
I can just.
Mean of cereal
Yes.
Yeah.
plus the mean of the bowl, right? But notice this, it says a cup of whole milk, and they, in order to make this, require half a cup.
So you divide by 2, so you get 70.
Yeah.
You mean for that one.
Good, so you multiply by 2 or multiply by 1/2 or divide by 2. And so with mean, if the mean of that is there, remember whatever we see with mean within this formula, right? We go ahead and do, right?
Yeah.
So we got, this would be 110 plus divided by,
Plus
2.
70.
so this would be 70. So 70 plus 110 is 180. That's why this would be C. Now here's where we become a little tricky, okay? Number 7 says the standard deviation of this. So I'm gonna come back over here and I look and see, well, this would be the same. So this is the standard deviation of C, right? We'll ask y'all, what would be the new standard deviation of T?
You want the formula?
Mhm.
So it would be mean X, or mean, it was both means of cereal and milk.
Mhm.
But you divide the milk one, so then it would be, what is it?
You mean
It'd be
standard
10 and
deviation?
Standard deviation, so it'd be 10 and 6. You square them, you add them up, and then you square root them.
Wait, 10 and 12.
No, but it's half the part,
Oh,
so it'd
yeah.
be 6.
Yeah, so this would be the square root of,
10 squared. Oh, sorry, you're doing the.
okay, you're good. So this would be of cereal squared plus 1/2 times,
Times milk squared.
yeah, and I'll do, M. This should be an M up here, just so you're not confused. M's there, right?
Yes.
But remember, before I go ahead and square this, I've got to multiply this by 1/2, right?
Yeah.
So I've got to find what is my original standard deviation, and then I square that whole thing. So this would be
10.
10 squared, square root. And then I have to half this first to get, this is 6 right here. Then I square it to get
36.
6 squared, which is 36. And then so 36 plus 100 is 136. Square root that would be
It's 11.66.
1.66. Good. Good, good. Okay. Awesome. Does that help kind of with the formula? That's a really
Yes.
good one. That is a really good one.
You also do number 9. That's the one where you have to use NCR, I think. I think it was that one. But I forgot how to do it, so I had to look the hard way.
Joe reads that out of it, kind of relates to 8, so I just want to make
Yeah,
sure.
we can do both. I just wanted to make sure we did 9.
Yeah, so Joe reads that 1 out of 4 eggs contain salmonella bacteria. So he never uses more than 3 eggs in cooking. If eggs do or don't contain salmonella independent, the number of contaminated eggs when Joe uses 3, what's the little n?
3.
3, good. By the way, because he uses 3, that's binomial, right?
Yeah.
It either does or doesn't contain salmonella, which that's an awful probability. I don't know, maybe that's me, but
Yeah, that's really high.
that is high. It's chosen at random, has the following distribution. Which answer would this be? It'd be B, right? Binom, N, and P. All right, in the previous exercise, the probability that at least one of Joe's eggs, 3 eggs, contain salmonella is about what? Well, this would be the probability of X being what?
Greater than 1.
Greater than or equal to 1. I heard that, Josh. Greater than or, did you say that?
I said 2.
Oh, I thought you were,
I just walked in and said 2.
that's what I
I had
laughed.
no idea.
I know,
I wasn't wrong.
Josh came
Yeah,
in
I
and
mean-
yelled out a number. Which, if you were right, that would have been awesome.
I kind of was.
Well, no, I mean,
Close.
I wasn't wrong.
This is true. So this right here, if it's greater than or equal to 1, and we're using binomial, what would be the only one that we would have to solve for and then subtract it by 1?
the binom PDF.
Binom
That's
PDF what?
PDF. I just started
I
stuttering.
can't tell if it's under or
Because we
not.
can't find
I
greater
don't
than,
know
right?
either.
We can't find greater than or equal to.
Oh, wait, so would it be the,
Binom
Binom
PDF.
C.
But I forgot
Binom
about that, so I
PDF.
didn't.
All right, you could do actually either one.
1 minus binom of 0?
Let's just do 0. And if we just did 0, you could do either or. But let's do binom PDF because it's only going to be 1, right? But you could do CDF. I could see that. Either one would work. PDF, NPK, right? If I was doing right here. N would be
3.
3, probability would be 1/4, and K would be 0. Okay?
Yeah.
So once I plug that in, I'll throw it down on my calculator here.
Does it do binom PDF on your phone?
Yeah, I've got a TI on my phone.
Oh, cool.
That costs anything?
Yeah, about $5. It's worth it, you know.
So if I were to do that, can I use my phone on the test then?
That would be sweet.
Hey Siri, what is the answer?
So, oh, sorry, my
That would be
Siri
cool.
went off, guys. It's good.
This is 0.422. Is that my answer?
Probably.
No.
No, we just found everything less than. So if it's at least 1, it's 1 or anything greater
Yeah,
than
so
1,
it's 0.5.
0.58. Okay. All right. How does this feeling?
Okay.
Better.
Can you do the
Better?
NCR version, or you just don't want to do it early for that
No,
one?
you can do that.
That's how I was doing it last night, and I couldn't figure out how to do it. So
Yeah, I'm good with that. You want to go ahead and do that? That's perfect. Trying to think here. Number 10 and 11. Each entry in a table of random digits has probability of 0.1 of being a 0, and digits are independent of each other. The mean number of zeros in a line of 40 digits long is. Ooh, this is a good one.
yeah.
Question: what type of what's number 10?
Hey.
What?
Oh, sorry. I just saw the options.
mean-
I didn't see the numbers in the problems.
What type of probability distribution is this?
That's a
It-
0 second. Zero.
It was-
Zeros, like zeros.
I can't read. Sorry.
Is it
Okay.
biome because you have 40 lines, so you have a set number of trials?
Good. Each is independent because it says it up there.
Yeah.
There's a set number 40.
Oh yeah, so you have 10 digits for it. It'll be B.
So the mean number is, remember, mu of x equals n times p, which equals 40 times the probability of getting a 0, which would be 0.1, which would be 4.
Good job, Josh.
Make sense? We're good
Yeah.
there?
Yeah.
10 lines, number 11, 10 lines in the table contain 400 digits.
I actually have to go.
You're good, man. You're good, Torrance.
Thanks.
Absolutely. I'm going. I'll do this whether someone's here or not. So I love talking to myself. It's weird, I know, but
You should make a YouTube channel. Like,
He has a
You do.
These hangouts
no,
go
but
on
like,
YouTube. I
not
followed
just
him.
that, just like make your own things, like vlogs, make a gaming channel.
Make your own vlogs.
I should. It'd be fun.
Just vlog your daughter and your soon-to-be son.
That'd be sweet. It would be sweet.
Should be.
10 lines in the table contain 400 digits. The count of zeros in these lines is approximately normal with what?
I mean, at 40.
Mean of 40 because it's n
Yes.
times p,
Yeah.
right?
And the standard deviation of
What's the standard deviation of binomial?
What is
Square root of n times p times 1 minus p, right?
Yes.
Yeah.
Would be the square root of
So
400.
N is 400.
Times
D
1, which is 40. Or 36,
Times-
I mean.
times 40.
Yeah.
0.09 times
So P
400.
is, yeah. Yeah.
I think it's 36, and then it goes down to 6.
You're right. Look at you. Jared already did this,
I
y'all.
told you I did it.
Man,
I would not have been able to do that in my head without the calculator.
That was
I'm
impressive.
proving you that I did it.
that's impressive.
Jerry just did
Um,
what he said.
All of them in your head, in his head. That's impressive. I'm just looking down as we go. Just remember, like things like at least as you're going. I think we did one similar to this, so I think we're good. Number 15 is a good one. Which would be most likely independent?
No.
I
Wait,
didn't get this
maybe.
far. I stopped after 12.
Or,
Dang it.
math and verbal school, possibly. Height. Wait, no, I thought that's night, not height. The height and night one. E.
Let me look at this real quick. Number 15, right? 15 is
You're
E.
right. It was E. Good job.
Oh, what we mean by that is which one is independent from the next, meaning knowing that one thing occurred doesn't affect the other.
Yeah, where should R?
You're right. Someone's height does not impact the average amount of homework the student does per night. No short jokes. All right, and that's true. That's why E's there.
Didn't do enough homework.
16. This is another one where we, this one. Okay, so if the mean is 50, right, with the standard deviation of 15, and each soda is $1.50, what is the mean and standard deviation of y, where y is the revenue? Well, what would I do with $1.50 with the mean and standard deviation?
You
Wait, what? I just zoned out for a second.
Yeah, you're good. So like with the standard deviation, each soda costs $1.50. On average, they have 50 that they sell, and the standard deviation is 15.
Yeah.
What could I do with the price and the standard deviation of mean? This is true. This is true. Wouldn't it be $1.50 times the mean?
50. So you get $75 in average revenue.
Yep. And then the standard deviation of this, which was originally 15, and this would be the standard deviation of x. When we multiply, does it change standard deviation?
Yes.
Yes. Multiplication and dividing, but
Yeah.
the adding and subtracting only affects the mean, right?
Yes.
Yeah. So this is 22.5, and this is 75. Average amount and the standard deviation is
So,
5 for distance from
Oh,
the mean.
not A. I meant D.
Yeah. Cool. Cool. I think we went through like one like 17. Yeah, this one's more like combining again. Random variables is geometric. Which of the following random variables is geometric? This is a good one. Number 19. The number of times I have to roll a die to get 2 6s.
That one.
The number of cards I deal from a well shuffle deck of 52 cards until I get a heart.
Also that.
The number of digits I read in a randomly selected row of random digits table until I find a 7.
Is this a list all question?
The number of 7s in a row of 40 random digits.
No, that one's
We
not.
know. The number of 6s I get if I roll a die 10 times.
No,
What one's that?
that's a loser.
Mine. Oh,
No, yeah, it is kind of.
Binomial, yeah.
Those are bad.
Number of cards I deal from a well shuffled deck of 52 cards until I get a heart.
Oh, number of cards. You're dealing all 52 is a set number of 52
Maybe.
until you get a heart. Never mind. Oof. No, because yeah.
All right. Binary.
Well, there isn't a number of.
Independent. Hold up. One's not independent.
Oh, B.
B
Because
is not
there's no
independent.
replacement.
Number of times I have to roll a die to get 2 6s. I think that one's off. I think it would end up being C, the number of digits I read in a randomly selected row of
That's
the
what I
random
was
digits.
thinking, but
Until I
Well,
find
why
a
is it
seven.
not A?
Because it said 2 6s. I want to
yeah.
make sure on 19, make sure I said that right.
Yeah.
19C, yeah. Because it's 2 6s, you know what I'm saying? Because it's almost like you have 2 successes. It's only until I find my first success. Then I end the game.
Oh, I was thinking rolling 2 dice at once.
Well, it says die, it says A die.
Yeah, it says
A die.
A die. So yeah, I just read it wrong.
No, that's good. That's a good point.
Josh, you're so dyslexic.
You were hating. I'm just blind.
All right. Probably that's
It's an old TI-84.
Oh, number 20 is really good.
TA2.
Number
It's
20,
like a TI-82.
number 20 is really good.
17 people that makes.
See if y'all can figure it out.
Wait. Oh, these are hard. Wait, nope, never mind. That was like the other one. I was like, never mind.
What are we finding? P of what?
The probability the hospital capacity will be exceeded.
Well, this is
Exceeded.
this is
Probability.
geometric, right?
Why?
Because there's no set amount of people.
You're just going into
Or no, or is it biome because there's 10 cases?
17 people
Oh.
have been exposed, right?
I guess I'm blind now too.
Yeah,
You're
it's
good.
especially contagious.
So is this bino?
Yes.
Yeah, this is gonna be bino. And what would be X? Probability of X has a capacity to handle how many cases?
10.
10. All right, talk to me on that.
Well,
So,
the probability of it being more than 10, of X being greater than 10.
yeah.
Greater than, oh yeah, so it would be greater than or equal to 10, which would be greater than or equal to,
11.
it should be 11, yeah.
Do you have to do the equal to, or does it not really matter?
It's just easier.
It's
Yeah.
easier to do the equal to.
If you just say greater than 10, I could see that. You should be
Well, I
good.
didn't know if like AP board wants it like with the equal to, and you have to go up one.
Are you using half person here?
Well, I didn't know if they want greater than 10 without the equal.
Yeah, I could see either. I would say greater than or equal to 11, although it's discrete, so it doesn't matter.
Yeah.
Like Josh was saying, which was actually a good point. So really, we need anything less than or equal to what in my binom? Because we'll do binom CDF, NPK. But wouldn't it be 1 minus this? Because we only can do less than?
Oh yeah. No,
Yeah.
wait. What's the problem?
Yes, he's right.
Oh.
He's the teacher.
No, it's a probability that'll be exceeded.
Yeah, so more,
Yeah.
but that does less.
Oh
See,
yeah,
yeah,
you're right. You're right.
that's
You're right.
less.
You're right. I don't know how to use a calculator, so
Oh, man. Well, you might want to figure that out tomorrow.
yeah, that's what I'm gonna do. Well, tonight.
Binom CDF would be NPK. N would be
10, no, 7.
17 is the total. P is
No, 11. Or what would you put in for? Oh,
so
that's-
these are independent, right?
oh, so 40.4.
40. Yeah, 0.4. And then this would be
What is NPK?
Oh,
So
K is accessory to like.
11.
No.
11. Yeah.
Yeah.
Oh, hold
That's
up. No,
where-
no, no.
No.
10.
It'd be 10, right? Because it's anything that's
Over
this
10.
or less than,
Or
right?
less than.
So
Yeah,
10 or
yeah.
less than,
Jake.
and then subtract by 1 from this, and there you are. Good.
Good.
Is this binomial or geometric?
This is fine.
You couldn't even read it.
Oh, I thought you were the first one. We just
Well,
went
you
over
could
that.
just look at the shape and know it's not what.
Well,
It's not
It's not Jim.
What is geometric? Always
always normal.
skewed. No, it's always
no.
skewed right.
to the right, yeah.
Always skewed right. It always.
Yeah, it's always
Okay. What would be the best description?
normal.
Josh is not normal. That's
That's
obviously
pretty,
skewed to be.
that's pretty normal.
That's skewed to, I don't know.
It's pretty close to normal.
I agree. So which
Wow.
one would be?
I'm blind too.
Yeah. Which one would represent this the best?
Well,
In order to estimate with a binomial, what must be true? N times P is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. What's N times P?
N times P is
For this one?
8 times
So
P,
0.8.
0.8.
0.08.
Not
Good.
greater than
0.08,
10,
yeah.
Once I check.
Yeah.
I also have 0.08. This is 0.8.
I think it's 0.8, yeah. No, I don't know.
The A?
No,
if you
you're
did-
0.8,
if you
you're right.
Yeah.
It's 0.8.
Yeah, my B. You got it right. And then what's N times 1 minus P?
One. Oh, N times
So
that'd be
0.9.
0.99. Yeah, so that's all pretty much. No, it's
0.9 times
speaking
8
English?
is like this.
I'm not. It's still not greater than 10.
Josh is still here. We're
It
good.
is not greater than 10.
It's 7.2. 7.2.
Something like that.
Okay.
Yeah.
Over here, 8 times 0.3 is 2.4. 8 times 1 minus P would be 0.7 times 8, which would be 5.6.
So
No.
So C then.
8 times 0.8 is 6.4. 8 times 0.2 would be 1.6. So which one would be the most normal?
It would be B or C. Could be either one. I have no idea.
You go with A because the standard well,
That's a
no.
tough question. I think what I would do, trying to pull this one up.
B.
B.
So
I was
The reason
right.
why I would say it is the closer it gets to 0.5 and the larger the sample size, the more normal it is. I don't like this question because, I mean, yeah, this would be the most normal out of this because the probability approaches 0.5. That's there.
what do you mean to purchase 0.5?
Like it's closer to 0.5 than 0.8.
Oh, okay.
Yeah, I mean,
Yeah.
that's a tough question. Yeah, it's just a tough question. Cool. Do you have anything else at all that you wanted to hit on?
I don't think so. Wait, could you go back to the review? There was a question that was kind of similar to this one, I think. It was on the review somewhere.
I think we did the whole review.
I'm a little confused on the
Oh, it was that one. Wait. On 12?
Mhm.
Oh, wait, no. Yeah, it was another one similar to the one we just did. I think it was A because it's 0.5, which is really close to normal.
is
I think that's what it was.
Which of the following situations would be appropriate to use a normal distribution to approximate probabilities for a binomial with the given values? Remember, n times p has got to be greater than or equal to 10, right? And n times 1 minus p is greater than or equal to 10. So the best one, 100 times 0.2, would be 20. 20 is greater than or equal to 10. That's true.
That'll be like 80. The other one. That's so weird. C works.
Which of the following would it be appropriate to use a normal distribution to approximate probability?
I don't remember. The answer was. Oh, I chose A, but it was C. I think that's what it was. When I was going.
Which one would be the actual answer in that case? Because
I thought it was A because
Okay.
A
was
would work
similar.
better than normal because it's just
All right, 100 times 0.99 is 99. That's
Yeah.
greater than or equal to 10. You're good.
Yes.
But 100 times 1 minus 0.99, that's the second condition, is
Not greater
0.01
than 10.
it's like
That's
times 100 is 1. This is not greater than or equal to 10, right? So this is gone. 10 times 0.5 is 5. That's not greater than or equal to 10.
Yeah.
Therefore, this one's gone. N times P, 40 times 0.88. It's 35.2. You're good there because it's greater than or equal to 10. 40 times 1 minus 0.88 is 0.12 times 40, which would be 4.8,
Which is not. Bigger.
which is not greater than or equal to 10. So this one's gone. 1,000 times 0.003.
That's just
I
too
mean,
small. Yeah.
It's way too small probability. That's gone. And therefore, we showed that over here, 100 times 0.2 is,
See, I thought it was A because the 0.5.
20?
I thought it made.
and that's
really
greater than or
approximately
equal to
normal.
10. Yeah, it looked like, right? Now, I know why you would say that. I see that. 100 times 0.8 would be 80, and that's greater than or equal to 10 here, and we're good. So this is what you would show, and then just say a comment on an FRQ that I can approximate this binomial with the normal
Okay.
distribution. And then you could go ahead and do normal CDF if you wanted to, with the mean and standard deviation you get.
Yeah, see, that's why when you said the 0.5, which is really close to normal, that's what you wanted. That's why I was like, I remember this one where I put it was 0.5 and it was wrong.
Well, 0.5 just means that that's the ideal probability to maximize it
Okay.
to approximate as normal, but the sample size has to still be high enough to be able to use
Okay.
that. Good question. Josh, did you have something before this?
sort of. I'm not good at the whole CDF PDF thing.
Uh-huh.
How do you do that?
He doesn't know how to use a calculator, remember?
Is it the calculator part that you don't get?
Yeah.
Okay.
Like, I don't know
You-
when to use CDF or PDF. I know sort of the difference, but
All right, well, give this to me. The probability of getting an ace on second card with replacement, okay?
Okay.
All right, first thing, is it binomial or genome?
that is binomial. Geonomial.
Why?
Yes, because yeah.
Or is
because
it
you get
geometric?
it's on a set number. Wait, is it? Yeah, it's on the second card, so it's binomial.
Yeah, it's something that's set. How many trials am I doing?
Doing two. Second card.
I'm doing it until I get a success, right? So probably getting an ace on the second card with replacement.
On the second, yeah, but aren't you only doing two trials if it's on the second card though?
I see the wording's kind of weird. The probability of getting an ace on the second card, or I would say, what is the probability? This is better. What is the probability of, or once you get an ace, you're done with the game,
Okay,
Find the probability
that's
of getting an ace on the second card with replacement. I see. That was
Okay.
weird. You could have taken that either.
yeah.
So let's say we do geometric. With that, this is PK. PK. No N because it's not a set amount. What's the probability of getting an ace?
4 out of 52.
Good. And what would be K?
K would be success. Would be 4 out of 52.
K is the amount that would when the game would end.
So 2.
2. Mhm.
Yeah.
So this would be the probability that x would be equal to
Oh, X would be.
2,
I
right?
need to stop working for a second.
Does that make sense? So,
Oh,
Go ahead.
genome there's only P and K, right? Because there's no number of trials, so you just skip the first.
correct. And I actually messed up. I didn't put something with genome, right? Is it PDF or CDF?
That would be C.
It's just one, right?
Just
Just one. So what is the probability
I
in
don't know
our
the
game?
difference between them very much. Okay.
Does that make sense? CDF is the value or anything less than that value.
Okay, and PDF is just straight value.
Straight up value. So genome PDF, 452, comma 2.
Okay, so if we're doing anything like with probability of something being greater than whatever, that we use CDF.
Kind of. So what is the probability of, within our game, once you get an ace, you're done. What is the probability, so it's still genome, what is the probability that you'll get an ace on anything that is either on the second or first hand? Second or the first hand.
That'd be 4 out of 52.
Still have 4 out of 52. Good. So this is genome. Is it PDF or CDF? If I say 2 or anything less than 2. At most 2, I could say.
That's still PDF, right?
Okay, so question. This would be probability of x. If
Yeah.
it's at most 2, it could be 2 or 1.
Okay, so
Which
then
would be
it's
CDF, right?
then it's CDF.
Correct. So this is now, when I
do
think of
What
this,
does CDF and PDF stand for?
cumulative. P, I don't even remember what it represents.
Oh, well, that makes sense. So C would get with cumulative, which means you add it all. Okay.
Anything
yeah.
to the left. So x is less than or equal to 2 is genome CDF PK.
Okay.
Remember that value or anything less than that value.
Okay. That was a really confusing example, but I think I got it.
Let me do another one. Is that cool?
Yes.
Because I don't want to confuse you.
Yeah, because I was just as confused now.
All right, I'm going to do this. I'm going to say I shoot until I make a shot.
Okay.
Okay. Based off that, what do I know?
You shoot until you make a shot. That. Yeah.
Is it binom or genome?
Oh, that's genome. That's genome.
Yep, that's right. Geometric. Good. We'll talk about 2 examples, all right?
Okay.
What is the probability? Let's go A. What's the probability of making a shot on my third shot? Okay. I am a, and I would give this on the problem. I am a 50% free throw shooter.
Okay.
Okay. Let's talk about A.
Making a shot on your third or by your third?
Just on my third. That my third shot would be a make.
Okay, that's 15%. Actually, no, that's given that you missed the first 2. So that's a little. So yeah, given that you missed the 2, that'd be 0.25 chance of that happening times the other 50 if you're making it. So that's 0.1.
Could I back up just for a second?
Yeah.
Use the same example because I think this is going to help you. Let's say I'm 60% because I don't want, I don't, because either way it would be 50, right?
Yeah.
So let's say it's genome.
Okay.
Is this PDF or CDF on A?
That is PDF.
PDF, because it's a shot on my third. It's one value,
Yeah.
right? P and K. What's P?
60. No. Yeah.
0.6. And what's K?
3.
Good. And I would plug that in.
Okay.
And when I write this in notation, that's the probability that x is equal to 3.
Okay.
That I'll make one on 3. Now, what about B? What if I say the probability of making a shot at most on the 4th? Okay. At
Yeah.
most on the 4th would be 4 for
That's-
anything.
Yeah, so that's 3 misses and then a make.
Good. So that would be the probability of x being.
4.
So it's 4. What goes here?
Oh, is less than or equal to 4.
Great job. This is genome
CDF.
CDF, and then it would be the same thing, 0.6 comma, well, except said 4, right? So the
Yeah,
K
so
would be
plus is 4.
4 or anything less than 4.
Okay.
Great.
Yeah.
Good
that's
stuff.
A much better example.
Good. My apology on that, by the way. I was trying to think of something on the fly. Binom would be the same thing, except if use the same example.
Instead of like taking a shot, it's like out of 100 shots.
Yeah, and shoot. This would then be 100 shots. And then the question A would be probability of making 30 shots, right?
Yeah.
Probability of making at most 50 shots.
Yeah.
And then you would kind of use that compare. Right?
Okay.
Binom PDF would be 1, Binom CDF would be that value or anything less than. Okay. Cool?
Yeah.
All right, thoughts, guys?
Good.
Good to go?
Good. Yeah, that helped a lot.
All right, I'm gonna do one quick thing. You can leave if you want to. I wanted to go over just the concept list real quick and just talk through this with everybody. This is gonna be really quick. If you want to go, though, go ahead. Chapter 6. What is a random variable? We talked about that at the beginning. Discrete, continuous. It has to be numerical, right? And it has to describe a random phenomenon. Okay. Part 2. Mean and standard deviation and combining them. We talked about that today, right? Means combine standard deviation. One cannot simply add standard deviation. Right here, we did one similar to this today. Remember the breakfast one?
Yeah.
Where we're going to have to multiply 4 times x and 5 times y, and then subtract them for the mean. But for standard deviation, you would multiply 4 times the standard deviation of x, 5 times the standard deviation of y, square them, add them together, take the square root of that. Right? Okay. We can talk over that too, maybe tomorrow morning if you have some questions. If you need number 3, come on in. Number 4, what's the difference between discrete and continuous? Look at some examples from online. Okay, discrete and continuous, recognizing that difference that's there. Number 5, things that defines discrete random variables. Things that defines discrete. I'm not sure what I mean by that. We know-
What was the meaning of like discrete? Like what qualifies?
Yeah, so it's like a probability distribution. That was crazy. I don't know if you heard that through the podcast, but that was crazy. So discrete might be like that has gaps, right? It's a probability distribution. That would be an example of that. Define discrete. I might need to look at the text and remind myself on that. But multiplication's impact on variance, expected value, and standard deviation. Here's the one thing I'll say. Let's say the standard deviation is 10. What would be the variance? 100, okay? Now hold on to that. What if I came here and said, okay, I'm going to multiply, let's say this is for x, right? And I say, okay, what is 2 times x? And I say, find the new standard deviation and find the new variance. Before I find the variance, don't multiply 2 by the variance because you'll get it wrong. Multiply 2 times the standard deviation first. So 2 times 10 to get 20. Then square 20. That makes sense? So this would be 400. If you do it the other way and just multiply this by 2, you won't get the right answer. So always find standard deviation before variance. Expected cost, you missed that. You deserve to miss that one. That one's expected cost, right? The x times the probability and then add all of them together. So like,
Expected mean.
Oh,
What's the mean
so
value?
it's just
Josh? Come on.
Okay.
yeah, like we're going to have x and probability of x,
Okay.
and then multiply these, add them
Okay,
together.
okay,
Yeah.
that's fine with that.
Binomial versus geometric versus normal distributions, knowing the difference between them. We approximate a binomial with a normal distribution if the law of large counts happens, right? N times p and n times 1 minus p have to be greater than or equal to 10, okay? Yeah, remember the acrostic for number 9? Binomial and geometric, what's the difference between those two?
Mm-hmm.
Probability and finding it with binomial and geometric situations. Yeah, I feel pretty good on that. Reviewing shapes as it relates to center, making sure that you can describe the shape. Oh, no. You know what this one is? All right.
That's cute to the
Which
right.
would be larger, median or mean?
Since it's on the left. Wait, what did you say? Which is larger?
Which is larger, median or mean?
Mean.
The mean is, right?
Mean is, yeah.
The mean would be over here.
Oh,
The median would be over
yes.
here. When it's normal, what happens? Mean
They're
and
the
median
same.
are the same. Good, good, good. Recognizing an outlier, just make sure you remember that.
Oh,
Okay.
gosh.
Just recognize
We got
it.
outlier formula up there, so that shouldn't be too bad.
You could use that if you need be. Why is randomization important in an experimental design? Say again?
It's the most accurate.
No.
Yes, I thought that's why I didn't say it very loud.
Okay.
That's why I didn't say that.
Randomization in experimental design. Experimental is where I place a
eliminates
treatment
bias.
on them. It eliminates bias, and then it allows me to show cause and effect because it's experimental, right? We put a treatment on someone. We put a treatment on someone, which allows us to randomly assign, which allows us to see cause and effect. Observational, can I show cause and effect?
No.
No. Can I show correlation?
Yes.
Yes, this correlates to this, but experimental design has to be done with a treatment. I randomly assign people into treatment groups, okay? Good. Number 14, independence and mutually exclusive formulas in multiple choice question. That would be one just to kind of touch base on. That would be mean if I actually put that on there. And I may have, but it may be an extra one. I've got to look and see, okay? But independence and mutually exclusive, just remember that, right? Just kind of have an idea of that one. Number 15 is the tougher FRQ. Give statistical justification by using expected value to compare two different equations, okay? All right, so you're just going to need to know expected value, and you have to, from what I remember, you have to come up with an equation that is there, okay?
What do you mean come up with the equation?
Yeah.
So if I said, am I about ready to give the actual example of it?
Yes.
A copier costs $1,000 to monitor each month. To fix each month.
To maintain or
Yeah,
something?
maintain, right?
Yeah.
I'm sorry. Yeah, how about this? For paper, it costs $1,000. Is that cool?
Yeah.
Additionally, there's a probability each month of 0, 1, and 2 of the number of times that the printer will break down. Okay. I'm just
That's
making
high
that
a
up.
month.
Yeah, no,
Two
it
times
is.
a month. Oh my
It
God.
could be per year or whatever. Okay.
It's
So this maybe is 0.5% of the time, or 50%. This is maybe 0.2, and maybe this is, let's make this higher. 0.4, maybe this is 0.1, okay? All right? The question that is comes up is, what is the expected cost that you would have within 1 month, okay?
Does it cost how much to repair?
Say
Or
that again?
Wait.
does
we
it
do
cost a
this
certain amount to
paper,
repair? Is that what you're saying?
Correct. I would say that it costs, per repair, it
It
costs $250.
Wait, okay. Are we going with the amount of paper or amount to repair it?
Both.
So
Right.
1,000. Okay.
Oh, we're comparing them. Okay.
So your
What's the
formula you would
equation?
come up with would be 0 times 0.5.
Okay, so we have to find the expected amount of fixes per month, right?
Yeah, that's what I was about to do.
0 times 0.5,
1 times 0.4, and 2 times 0.1.
4, 2 times 0.1. And that would be 0.4 plus 0.5 plus 0.2 would be 1.1.
Yes.
So 1.1 would be the expected.
So
Expected
times
fixes.
250.
So yeah, so technically the equation, right?
Wait, that's 0.2 plus,
All right, this is
0.4.
0.2,
Plus
0.4.
and that's 0. The other one's 0.
Oh, this is 0, my fault. So
Yeah.
that'd be my fault. You're right. Josh.
0.6.
Good, that's why I got you out here. Nicely done. 0.6 is the expected amount of fixes, right?
Mhm.
Per month. So the expected cost that I would pay per month for this printer would be what? Give me the equation.
So it would be, I have the answer. So wait, in total cost,
Mhm.
so you would do 0.6 times 250 plus 1,000.
Yes. So technically the formula is $1,000.
Yeah.
That's flat.
Yeah,
Yeah.
that's flat.
Plus 250
Times 0.6.
times this. I mean, I'm giving you a lot right now, I'll be honest with you. I'm giving you a lot. 250 times X. The expected number of times it's breaking down is 0.6. So 0.6 would be here. 0.6 times 250 plus 1,000 would be the expected amount that you would have there. Okay.
So if you were to do this, would you solve for or just leave? Oh, this is just the formula. But I mean, would you want to do the x or would you plug in 0.6 in this equation?
0.6 into the equation.
And then show that and don't solve because it just wants the formula.
No, I would give the actual
Yes.
total.
So
Because you're going to see
1,150.
which one, you're going to try to compare two items and which one would be the better option.
Oh, so you're printing a different printer that costs like less
Yes, I
paper,
know,
but-
I look so ratchet right now. Yes, that's
Yeah,
right.
that's better.
The better, I probably should just leave it like this.
Yeah.
All right, that's the first FRQ. Yeah, and that
Oh,
literally,
so
we had
it was
16.
it was kind of like the wager one. Which wager was better based on the expected value? Okay.
100%. 100%. So to be honest, it takes some critical thinking on that one.
Okay.
I put the tougher FRQ because it is. And then FRQ number 2 is recognizing the differences between binomial, geometric, and then using it to solve specific word problems. Okay? So remember the differences. That's the big thing. Okay? Guys, y'all are rocking. Do you have any other questions for me?
I think that's good.
Man, that's a good review right there. Hey, I'll tell you what, we don't mess around in here. Should we do one more shot just because?
Yeah. You know, I made
Hey,
one.
here we
You
go.
have to top.
Should go.
All right, I got to top Jared here. All right,
You
let's
can
make a
walk
bet
away.
here on the podcast. Let's make a bet. All right, if I hit this shot,
Okay.
You're at 60%.
No.
if I hit this shot, then
You all
Next
get
week.
A's.
next week y'all got to bring me coffee every day.
But if you miss, there has to be a.
If I miss, each of you get a shot, and if one of you make it,
I already
I
made my
will-
shot. That's not fair. I already made my shot.
you have to do it again.
It's independent. It doesn't matter.
It is, yes, that's right. If you all hit the shot, then one question can be thrown out, not on FRQ. One question can be turned into a bonus for tomorrow.
So me and Josh right now.
If you hit the shot,
If we both make it, can we get 2 questions?
no, it's got to only be one.
Ah.
Okay? All right, here we go.
I already made my
Here we
shot.
go. You
though.
ready?
It's not
Here we
fair.
go. Oh! Yes!
Do we stop it?
Yes!
That's not.
Woo! Get you some. Get you some. All right, y'all get a shot. Y'all get a shot. This is to null it.
Wait,
I will still give the deal. I will
wait,
still
wait,
give the
from-
deal.
from where?
If one of them makes the shot.
Right. Oh my gosh, I can't throw that far.
I'll leave it up.
Move it
I'm
up,
very
right there.
confident. Here we go. Yeah, I could bet anything on that shot right there.
I'm going for 2 for 2. I'm 100% free throw shooter.
All right, here we go.
Dang,
Wow.
dang, dang,
Dang.
dang.
That was epic. That was epic. Hey, have a great day. Hope this helped. Be blessed.